So in the last segment, we developed this pair of formulas for the sum of a geometric series. We saw that if you have simply the sum from n equals 0 of r to the n, its sum is 1 over 1 minus r. I think many people learned that formula in a high school algebra class. The important thing to recognize is that that formula, as well as the other one, only apply when the absolute value of r is less than 1. In other words, when the common ratio is between -1 and 1, exclusive of the endpoints. The second formula is sum from n equals some arbitrary value m up to infinity of cr to the n. So we're just introducing the possibility that we start at some index other than 0, and also that we're possibly multiplying each term by some constant c. So we can use this to evaluate the sums of various types of series. So let's start with this one. We have the sum from n equals 0 to infinity of 5 to the negative n. So let's see. How do we evaluate this? Recall that we can use this formula. We'll use the simpler version of the formula here. We have the sum from n equals 0 to infinity of r, I don't need parentheses there, of r to the n is equal to 1 over 1 minus r, as long as r is less than the absolute value of r is less than 1. So if we look at this, we don't have quite the form that we need. We have up here we have negative n, and here we seem to have a base that is outside for which it's certainly not true that its absolute value is less than 1. But if you look a little bit more closely, I can rewrite 5 to the negative n as I can rewrite that as 1 over 5 to the n, which is also equal to, since 1 to the n is the same thing as 1, I can rewrite this as 1/5 to the n, and now I actually do have a value of r. So, and we can easily see that 1/5, the absolute value of 1/5 is less than 1. So therefore, this series does converge. In order to find it, we can say that we're just going to apply the formula. Having identified r, we write 1 over 1 minus 1/5. That equals 1 over 4/5, which equals 5/4. So that's the sum of that series. Got another example here. Let's move that a little further down. We have another example where we want to find the sum from n equals 3 to infinity of 7 times -3/4 to the n. So recall that the sort of expanded version of the formula was n equals m to infinity of cr to the n is equal to cr to the m over 1 minus r. So what we have to do here is just identify cr and m, and in general that's going to be the case. What you want to be able to do for any series to find any geometric series to find its sum is you want to be able to write what c, r, and m are equal to. We can easily see that m is equal to 3. That's the starting point. We can see that c is equal to 7, and r is equal to -3/4. It's certainly the case that since the absolute value of r has to be less than 1, it's certainly the case that the absolute value of -3/4 is in fact less than 1. It's between -1 and 1. So we can proceed and simply write that the given summation is going to equal 7 times -3/4 to the 3 over 1 minus -3/4. So that comes out to 7 times -27 over 64 over 7 over 4. I can actually simplify this further. This is going to be 4/7 times 7 -27 over 64, put that over a 1. I cross those out because they cancel, and that actually gives me 4 times -27 over 64, and 4 divided by 64 is the same as 1 over 16, so this is -27 over 16. And the point is that these geometric series do have sums that can be found fairly easily, or in the case where absolute r is greater than 1, we'll be able to very easily identify that it has no sum and that the series diverges. Let's go to another example. This one is evaluate the sum from n equals 3 to infinity of 3 times 2 to the 2n over 3 to the 4n. So the trick here is going to be that we have to put this in the form sum from n equals m to infinity of cr to the n. And we don't really have that. What we have is we have something raised to the 2n and something raised to the 4n. We're going to have to simplify this a little bit. So the thing to recognize here is that 2 to the 2n, I'll just write this here. So 2 to the 2n is equal to 2 to the 2 to the n. That's just a fact of the fact of how exponents work. That a to the b to the c is equal to a to the bc. So we can rewrite this in that way, and we get the sum from n equals 3 to infinity of 3 times 2 to the 2n over, this is going to be, for the same reason, this is going to be 3 to the 4 to the n. So that equals sum from n equals 3 to infinity of 3 times 4 to the n over 3 to the 4 is 81 to the n, so that's 81 to the n. This can be rewritten as sum from n equals 3 to infinity of 3 times 4 over 81 to the n. And once it's written in this form, we can easily see that that's r, that's c, and that's m. As always, the combination of c, r, and m will completely define our answer. So that's going to be c is 3, m is 3, and r is 4 over 81. We'll do a final check. Is it the case that absolute value of r is less than 1? Yes, certainly is, that 4 over 81 is between negative 1 and 1. So this sum is going to be 3 times 4 over 81 to the 3 over 1 minus 4 over 81. It's not even really worth simplifying this, so we're just going to leave it in this form. But just if you want to, just convince yourself that the sum from n equals m to infinity cr to the m is of cr to the n is equal to cr to the m over 1 minus r. You can convince yourself that that has been correctly applied here. So let's show that whole problem.